Which transformation is equivalent to rotating a figure 90 degrees counterclockwise? Okay, so the first thing I would do when I would see this problem is I would read the answer choices and try to throw out ones that I know are wrong. So, for example, like B, it says reflecting over the X and Y axis. I know that if I reflect over both X and Y axis, that's a rotation of 180 degrees. That's not going to be a rotation of 90. So I'm going to go ahead and throw that one out. And translating 2 units left and 4 units down, if you just shift it left and down, you're not rotating it at all. So that's not going to be the same as rotating 90 degrees. So I'm really just left with 2 options here. And in order to do this, it helps to visualize. Well, let me mention this. It also helps to really know your mapping rules. So here they are in case you forgot them. You can take a snip of those and study them again. But if we want to rotate 90 degrees counterclockwise, this is the rule that we're going to apply. We're going to put the Y first and change the sign, and then the X. So a 90 degree counterclockwise rotation gives us this mapping rule. Now I would like to go ahead and visualize it because I'm really visual. So let me show you what that looks like. Now this particular question just said a figure. It didn't say what it was, so I just created myself a triangle. And I just found the original ordered pairs, 1, 7, 4, 1, and 1, 1. And then I'm going to apply that 90 degree counterclockwise rotation. So I'm going to put my Y value first and change the sign. So it's going to be -7 first, 1. And I did that for each of these ordered pairs. I applied it. So now let's look and see where that 90 degree counterclockwise rotation would end up at. If we went back here to -7, 1, and then we did -1, 1, and -1, 4. This would be our triangle that we're looking for that has undergone a 90 degrees counterclockwise rotation. So we've taken this triangle and we have rotated it 90 degrees counterclockwise. And I know we mentioned a long time ago, but a helpful hint, if you're rotating 90 degrees, it's going to move 1 quadrant. If you're rotating 180, it's going to move 2 quadrants, and so on and so forth. 270 would move 3 quadrants. So this just kind of gives you a visual of where we should end up. So now let's try some of those answer options. All right, the first one said to reflect across the x-axis and then reflect over the line y equals x. So if I take my original triangle and I first reflect it over the x-axis, I would flip it and it would end up right there. And then if I've just reflected over the x-axis. Then if I reflect over the line y equals positive x, that's this line right here, y equals positive x. If I reflect over that, notice here this distance is 1 unit, so I would want it to go 1 unit in the opposite direction. This distance, this diagonal distance from that point to the line of reflection looks like it's like 1, 2.5. So I would want to go that same distance in the opposite direction. So basically, if I fold my paper right here along this line, this triangle would end up right there, which is what we want. But I want to show you if you tried the other one, if you just tried to visualize it, y'all, you don't have to go into this much detail on the test. You're just trying to visualize. So if you reflected it across the x-axis, and then you reflected it across the line y equals -x, it would just kind of flip right there. And it would not end up here in the second quadrant where we wanted it. So this is a way to visualize it. When I did it originally, I did not graph it out like this. I wanted to go a little bit further to show you. I just, in my mind, I imagined, I said, okay, if I rotate 90 degrees counterclockwise, that's going to move it 1 quadrant. And then I just started imagining, well, if I take a figure and I reflect it over the x, and then I reflect it over the line y equals -x, it's not going to end up in that same quadrant. So I kind of did it in my head, thinking about which quadrant it would end up in. But this final answer here should have been this one. We're going to reflect it over the x-axis, and then we're going to reflect it over the line y equals positive x.